everyone. I'm going to talk a bit about the business side. And this is a presentation that is one that we give, it's not technical. And I've done that purposely because what I found is sometimes we very quickly get into the detail of how all the technical architecture works, data, and it's all very, very important. Most of my day, when I'm back at the office, is spent thinking about how do we get our data structured, and how do we think about data sources, stitching them together. So I'm happy to talk about that, but I find that we sort of have to go back to the basics about why we're doing, why we're using data, what's the business case, how do we make the case for making it important and useful, and so that's what this presentation is about today. So many of you probably know about TfL, you've used our services, but I wanted to just start by talking a little bit about who we are, and then I'll talk about our data and some case studies on how we've used this data for customer benefit. So we're a big organization. We are one of the most integrated transport organizations in the world, so you can sort of see with all of our roundels. We have the underground, we have buses, we have the overground services, we have congestion charging, cycle hire, and we have the strategic road network. So what's particularly interesting for a public transport organization, and one of our challenges and opportunities is that we have both sort of your traditional public transport revenue collection sort of data, and we also have traffic signal data, we have sort of road network assets, and so it's a really big sort of bucket of information that we have to stitch together. And we were set up in 2000, and we were responsible for basically making London grow, work, and move, and make life better. And one of our biggest challenges right now, and exciting opportunities, is the fact that London is growing. So we really have to plan ahead to meet the challenges of sort of growing to sort of 10 million Londoners. At the moment, we're already at a record high. We have 8.6 million Londoners as of February this year, and that's the biggest number we've seen in history. And in addition to that, just general sort of population growth, there's this huge rise in expectations from our customers about how they want to access information, how they want their services to be personal and relevant for them. So this will be no surprise to all of you, but we feel that data is gold dust. It's really at the center of what we're trying to do here to deliver better transport. We talk about the fact that we're not just a mobility company, we're not an infrastructure company, but we are a data company. And we need to sort of highlight and sort of make our data really at the heart of what we're doing. And so there are two strands of that. There's an open data strand, and this is how we make our information available, freely available to the public, to developers, to sort of basically anybody who can take open data and make and innovate and power travel information applications and tools. And that's been a policy focus of ours for, it was about 2007 and 2008, we began to think about this, and we've been sort of really pushing this forward. And so we have, I think, about 360 different apps that are out there powered by the open data feeds that we have. But I'm going to talk to you about the big data work that we're doing. And again, don't really need to sort of define what that is, but that's what I'm going to work through today. So we're big. We have 46 million bus journeys a week, 25 million London underground journeys a week. So just in terms of data volume, we have a lot of data to think about. And so, as I mentioned, because we are operating all these services, we have a huge set of sources of big data. We've got our Oyster and contactless cards, and that's the area that my team looks after. We have a range of traffic information that's coming through our systems, and that's really a lot of that is asset data, also ANPR camera data as well, and it's basically sort of to keep our operations moving. And we have bus location data that is sort of saying where our buses are, and also events data on our buses, so if the bus opens its doors, we were recording that as well. And then we have, of course, other data sets that we can bring in, like social media. And so what do we do with this data, right? Because you have lots of data, we need to sort of make a case for an investment into it. We need to think about what we're doing with it. And what we started with is basically sort of your customer information, sort of email sort of data, and how do we service our customers there. And we now have a database that has 4 million email addresses of people who've opted in to get information from us. And that is basically gathered from sort of Oyster data. We don't require people to register for Oyster or for contactless cards, but if people want to register with us, they can ask to also get service information from us. We also have cycle hire data. We have other various different data on low emission zones. We basically have a great big sort of data set of people who want to get information from us. And so we push out email. We push out a lot of emails to them. We sent 260 million emails. Now, the challenge for us is to make sure that the emails that we're sending out, of course, are relevant, because we want to make sure that we're sending useful and targeted messages to customers, and that we're not bombarding people with lots of stuff that's not relevant to them. So we have a general email. Many of you perhaps get this that we send out each week that will say, and here are the various different either special events that are happening. Be mindful if you're traveling around the network, or a list of all the sort of different closures that we'll have on the underground for engineering works. But we also target the email specifically by looking at sort of travel patterns of some of our customers, so that we can say when we had to close Tufnell Park because we were replacing both lifts at once, which means that customers who live in North London will have to go to one of the other stations. So we wanted to make sure that our customers knew that well in advance. And so we would look at sort of travel patterns and identify who would find this information useful. And we've gotten, we think we've gotten it pretty right, because we have surveys and we check on this, and we get 83% of our customers who say, yeah, the service is useful and very useful. So, that's sort of a standard. It's a good thing that we need to be doing, and it can get sophisticated a little bit, but some of it is fairly straightforward. But what I'm going to talk about next is really more sort of data science work that we've been doing. So one of our challenges has been, for years, with Oyster, you can see where someone taps on a bus, but we didn't know where someone exited. And our bus network teams, of course, want to know where people are going from and to. And they really want to understand, even beyond just on the bus, where are people transferring to the tube, how are people traveling? Because that, of course, means that we're planning a better service for our customers. And the challenge that we found is that, well, with just Oyster, you have a tap on, but nobody taps off. The question could we use sort of big data to basically infer where someone got off the bus? So we have two data sets. We have our Oyster data, and then we have our iBus data, which is the bus location data that you'll see when you see either on the countdown signs or on your phones when the bus is coming. And that events data is sort of saved and recorded and sent back to us. It will also say, did the bus stop? Where was the bus at a given point in time? Did it open its doors? So what we've done, and we did this work working with MIT. We have a number of research partnerships. We've had one with MIT for a long time. And we said, okay, if we have sort of a bus here that's yellow, we know where the tap is, because we know where someone taps on the bus. We know the timestamp, we know the location. And then then we can look at where the next stop is. So if you see the next tap of a customer, and if you see it that's at this stop X, we make an inference. Now it's an inference, it's not precise, but it's pretty good. We're looking overall the whole network. It's good enough for us to sort of understand, yep, very likelihood that they got off here at this stop N. Or if you see that the next tap is over here at this underground station Y, we will sort of assume that they likely got off at stop B. So we have a whole sort of set of decision rules. If the stops are really, really far away, for example, we would just say, oh, you know what, we can't make an inference here. The time has to be within a certain parameter of time. Otherwise, we might say that if you see someone in the morning over here at this part of the bus route, and you don't see them again to the evening, but you see them over here in the evening on the same bus route, you may assume that they're just commuting back and forth to work. And we can match the sort of origin destination, but we wouldn't count it as a journey, because obviously what they did is they went in, went to work, and then returned. So by doing this, we get about an 80% inference rate on the network. And what we've done is we've taken anonymized, so basically hash, so our Oyster data IDs, and we have a year's worth of data that basically every day that does sort of origin and destination inferences. And so what we do is we sort of look at this, and we're looking at how we can use this. And there are a couple ways that we can use this. We can monitor overall congestion on the bus. And we can sort of look at a route and look over time, and you look at sort of the bus runs, and say, well, perhaps over here, it's getting pretty high. Like, do we need to change bus services? Do we need to sort of put in extra capacity? And so that's sort of it. We can sort of use this in a way that we never really had before. Because before, we would do these surveys, where you basically, you'd do one day every few years, you sort of hand out surveys to people. If they were going only a short distance, probably you wouldn't fill them out. Surveys are very costly, you don't get a great return, and you certainly can't do it every day for over a year, which is what we have here. The other thing that we've done is last summer, I don't know if some of you may remember, but Wandsworth had to close Putney Bridge. They found there were emergency bridge works that needed to happen on the bridge. And people could walk across and you could cycle across, but you couldn't bring any cars across and you couldn't bring a bus across. And so all of a sudden, we were scrambling to say, right, what do? We had a number of bus routes that crossed over the bridge, and we had to understand how many customers would be affected and what's sort of the right solution for these customers. So what we did is we used our iBus and our Oyster data and our tool to sort of predict how many bus passengers would be affected by this. And so what we found is that we had about 40,000 users made about 111,000 bus journeys a week, roughly, that crossed the bridge. And this was just particularly on the segment that crossed the bridge, because you could look at all the bus routes that went over it. And before we had this origin destination tool, we probably would have been stuck looking at it at a very granular level and trying to make some assumptions about it. But we could really target into those journeys that crossed the bridge. And then about half of those journeys would either start or end very close to the bridge. So we could make an assumption that it would be inconvenient, and it would not be ideal for customers, but they would only likely take one bus, right? Because they would either walk across the bridge and catch the bridge on the other side, or they would basically finish a journey and walk. So it would be one bus route. But that left about half of these journeys where the bridge crossing was right in the middle of the trip. So for these customers, we had to, sensibly, we figured that, well, they take a bus from where they started, they get to one side of the bridge, they walk across the bridge, and then they get on another bus. So for these customers, we had to think about how did we help them so they wouldn't be charged twice. So we see this little transfer card here that we set up. It wasn't particularly high tech, but it's a short enough period of time, and it worked for these customers where we were able to sort of manage them so they wouldn't be charged again. We sent, going back to the earlier slide, we sent emails to the customers who were likely to be affected. And we also did a little bit of route changes, understanding that we might be able to provide alternatives going to Hammersmith or going to other places where they could make transfers to stations and avoid the area. So that's what we did with that. And another case study I wanted to talk to you about is some of the work that we do on sort of automated fare refunds. So you may have seen in the tubes, you may have seen advertisements and some service information about the fact that we offer refunds that we have if customers are delayed. And we do that because we have sort of a refund charter that says that if you're delayed for more than 15 minutes on our tube, then it's our fault. Or for more than 30 minutes on the underground, you're eligible to claim for a refund. So we have to sort of have a system in place to sort of manage that. We also find that sometimes, because of our contactless and our Oyster system, that customers make mistakes. They don't mean to, but they miss a tap. And because our fare structure is such that we need to, it's a zonal system, if you miss a tap and you're traveling on a pay-as-you-go fare, you're charged the maximum charge. And we do that because, of course, we need to collect our revenue, but it's not the aim to catch people out. So we have sort of algorithms that we run to basically to refund customers who make a mistake, and to basically for people who claim for a refund when it's our fault, to verify and pattern match to make sure were they traveling, was it our fault, and then we offer them a refund. And sometimes, when it's a particularly poor service day, a couple times a year, we will say, actually, customers don't need to even claim. my team goes through the whole day's worth of travel and identifies all the customers who were likely affected, and we push out the refunds to them. And then another thing that we do with our data is we look at who's traveling on the network. And again, we do this by taking the Oyster and contactless data, we hash and we remove identifying information, but we can look just on taps alone at the different types of customers. So we've done clustering, and this is again another project we've done with MIT, where they are taking different taps and building up profiles and clustering the different types of users. And you can see, you have a group of users who are regular users. They tend to be using the system frequently. They're starting in the morning. They don't travel to a lot of stations. They're pretty fixed in terms of their travel, and you can see them. See they're about 36% of the group. But we also see that there are a number of people who come in either because they're really visitors, and visitors are starting later. They're generally having breakfast at the hotel, and they're on sightseeing. They travel to a lot of different stations. They're not showing up for a very long time, but they're traveling around the network. And then you have people who are just very infrequent. They're not your typical commuters. And this was really useful for us because I think many of us have tended to operate with this perception that you have, people are very regular, they always travel 5 days a week, they always start at 8 in the morning, they go through the whole day, they return. But we know, yes, there's certainly some people who do that, but there are a lot of other people who are much less regular than we think. And that helps us in terms of understanding who's on the network, what their needs are, how do we communicate with them. And it's by doing it really at a granular level that we can pull out the data to analyze this. And this also helps with how we plan out our stations, how do we talk to our people who are retailing in our stations and providing good service for our customers and for us as well. And then the last piece that I'll talk about today is we also looked at flexibility in travel. So we know, going back to the challenge, we have more and more people traveling. We have more people traveling in the peak. Peak is very, very tight. There's not a lot of capacity. So we've looked at ways, whether by providing information about travel patterns, whether people who can be flexible, would they like to be, right? Because some people have no choice. Some people just want to go at a particular time and are very fixed. But some people may not know, particularly go back to the slide that says we have a lot of people who are not regular and frequent users of the system. They may not know how exactly that it's busy at a very narrow point, and then there's a little more capacity a little earlier, a little later. And so what we did is we did a trial. We did leaflets, we did some posters, we sent out emails to say, this station is the busiest time between 8:15 and 8:30. If you can travel outside this time, you might have a more comfortable journey. You might want to consider it. And so it's a difficult message, right? Because everybody wants to travel when they want to travel. And you certainly don't want to be saying, I'm sorry, go travel now. But sometimes some people might not know. And we wanted to see whether we'd have any effect on it, in terms of general peak travel. And the answer is maybe, right? We can certainly see some shift in the the before message and then the after message. The question, I think there's still some questions here to say whether, would this be sustained? Do you always have to give this message given the churn in the system? Will people try it for a little while and then find out, it actually is just much easier to shift back to when I want to travel? So it's early days, but it was interesting to see how you could use our data to see how a message would have an impact. So what do we do next, right? So there's lots more. This is one subset of data, but we really want to think about how do we integrate more data. So how can we do a better job of integrating our incident data? Right now it's semi-manual, but it'd be great if we had a whole really structure where we brought in our incidents information. And we're beginning to bring in train data, so loadway and location data on our trains in as well. The road network, there's a huge opportunity to think about our buses and their iBus data, as well as the ticketing data, as well as our camera data and our scoop data, which is sensing sort of the traffic signal loops. Looking at weather data, looking at social media, and then I think the challenge for us is how do we bring this to life? Because we have to be able to communicate this to both some technical audience to understand the sort of the service patterns, but also to just the general public, to people who are in marketing. So how do we communicate the messages to senior management, to everybody? And how do we do that effectively? And what are the new tools and techniques that we can do? So that's what we've been up to. And if you don't have any time for questions now?
Okay, good 5 minutes.
Okay.
Unfortunately, Lauren's not able to stay for the panel debate later, so if you've got a question for Lauren, now's the time.
Yeah. And also we're hiring, so I should also say that.
And then I'll take a photograph of that, tweet it, because that might be of interest.
Great.
A couple of things struck me as you were talking, so I've saved them up. The last one mentioned offering sort of, you might have more comfortable journey if you travel outside peak. Have you looked at actually offering different fares?
Well, so fares are interesting because fares are set by the mayor. We do have peak and off-peak fares already, so there is, and we do communicate that some. The whole fare, we did a lot of thinking about how do you do this with fares policy, ranging from how do you communicate it. It's already very complicated. Sometimes people say, oh, it's too complicated, make it simpler. Of course, if you make it simpler, then it can't be as precise anyway. So, there's a question, do you say more comfortable, do you say more reliable? Because we do know that the journey time reliability is difficult in the peak when you have so many people. We can see a correlation between train reliability and the numbers of people, particularly when you think about people leaving out the doors or trying to get in and the trains are held. So there's some questions about how do you communicate it, and how do people respond to that, and also what's happening on the network. But fares, certainly possible, but it's more complicated.
People with a freedom pass, is that a significant amount of journey the older population?
Well, so we do still have, and again, freedom passes would be free travel. So certainly fair, and also people are on season tickets. So again, their travel is free all the time. We certainly see some, and for a while there was a time where you could use a freedom pass before 9:30. For now, on our services you can. We could certainly would see some of that when we brought that in.
What challenges is the move from Oyster to contactless cards presented to your analytics?
Actually, well, no. So we get all the data, right? So I was involved in the building of the contactless payment. So what happens with a contactless payment card is that the card is presented to the reader in the same way an Oyster card is. They're two separate systems. So one of the challenges for us has been a sort of data challenge to make sure when you bring in the data structures that they're similar to a data warehouse. But the data itself, we get basically, it's tokenized because of PCI compliance. That's done at the reader. What we get is a token of the contactless payment card, but then we essentially get the same data that we could get on an Oyster card. If you don't have to register, if you have an Oyster card with an annual pass or a monthly pass, you have to register with us because it's a higher value product. You don't have to register it with a weekly or pay-as-you-go on the Oyster, other people do. It'd be interesting to see the rates of registration because if you don't register, people register in part your contactless card your Oyster card because they're afraid if you lose it, you want to be able to pay it back. With your credit card, or debit card, it's not an issue. So it'd be interesting to see whether our overall registration rates change. However, our offering about registration is really about getting service messages. So if people are finding it valuable, then it's useful to know, then they want to know the service, and that's the offer. If they don't find the service messages from us valuable, they won't register. So, but otherwise, the data itself, we get as much same data.
So you'd register your debit card that you use instead of your Oyster card? No?
Well, so the way it works is that if you want to travel on the system today, you can do two things. You can go get an Oyster card, and we've issued a lot of Oyster cards. Okay? We've issued probably 100 million. We see a regular usage. about 9.5 million Oyster cards a month. Or you just show up, pick up your wallet, and you have a contactless payment card. You basically just use it. You don't have to register it. You can, but the data that you have, the data that we see from a usage point of view, is the same. We can see the taps, the locations of the times.
I noticed you can't use money now on the buses, and a lot of people that they don't use the public transport much, they get on and they're really surprised they can't buy their way onto the bus, and they have to go, they're turfed off and they have to go and find a shop, you know.
Oh, we were finding, I mean, we did, it was a long decision to take away cash from the buses. We were finding that there was a very low percentage. It was very expensive to handle the processing of it. So that's, again, contactless payment allows
And security as well.
Yeah. So, yeah.
But back to the previous one.
This one?
Yeah, the social media,
Yeah.
integrated social media with our customer data for deeper understanding. That's what, their Facebook or?
Well, Twitter, right? So, yeah, I mean, most
So
Facebook,
what they're
most
saying
Facebook
about-
was, we haven't looked at Facebook, because a lot of Facebook
That's
of course
true.
is private. But Twitter is public, people are broadcasting and tweeting. So what we could look at, are we right in terms of when we put service delays in the network to say it's big delay, minor delay, severe delay, and are people tweeting that there's a problem, right? And are we right in terms of identifying problems and in terms of disruption, in terms of timing? So that's sort of what we would do with that. Let's see, I think.
You mentioned briefly about weight sensors on trains. I actually went to see Bombardier last year, trained with the train manufacturers, and they were talking about sensors on trains, weight loaders, but also inside sensors that can actually count people. And you could obviously put that technology into stations. How is IoT affecting your future plans?
Well, so the moment what we have is we have a train fleet that has basic loading data that we can use already to sort of estimate how many people are on. So far, when it was set up initially, it was not spec'd in a very precise manner, and everybody thought, oh, who made the decision? All you need to know is it 1, 2, or 3? 1 is light, 2 is medium, 3 is heavy, which is, of course, of no use to anybody at all. So the first challenge is to try and get it at an actual granular level of the data, and then get it in a sort of a quicker time. Sometimes with the overground, for example, it's days later. So the first challenge is to get that information in quickly. We're seeing a little bit more. We have right now I have a trial where we're taking in some of those data and we're beginning to analyze it. And what we've done is we've set up our data is we have a customer data warehouse, but we can bring in other data feeds into a sort of exploration area, and that's what we've been starting to explore and see. But I think that's the whole, it's getting all that sensor data and combining it all together is the real sort of aim of the win on that.
You started by giving the case study of the origin destination tool, and you gave an application at the closure of Putney Bridge. But what motivated you in the first place to create this origin destination tool? What was the killer app you had in mind? Or did you just think, oh, this is an interesting thing, let's do it, and then find the uses later?
Well, I mean, the basic discussions we had was us with my team and the network planning team and MIT as well. We were sort of discussing what are some of the challenges. And one of the challenges is really the planners who are planning the bus network don't have a lot of detailed information. They said, we do these surveys, they're really expensive. They don't get us a huge amount of detail. Could we get more? And they saw, because we started with it on the tube, they saw that we were looking at origins and destinations on the tube. And that was sort of the saying, right, could we do something with the bus? Because we already know where people enter and exit on the tube, and they could see that on the underground that was useful. So, do we need to?
We'll do one more.
Is there any plans to upgrade to a system like the use in the Netherlands?
Is there a smart card system, or?
It's a national smart card about the Oyster, but there's a lot more route information. So as I'm travelling on the network, I can make real-time decisions based on the information I've got in my carriage to switch carrier at the next point. So I've got all the next on transport links shown to me. So I found whether it's a station or a bus. So it's all integrated.
What I would say is that our ticketing sort of movement is towards
This
contract
is not
listing.
ticketing, this
But
is
in terms of better information, there's a huge range of opportunities in personalizing how that is and how customers would see it. So the aim is, how do you push out that information individually? We need to understand more about the individual sort of granular levels.
Well, you get journey times for
then-
your current journey and all the stops.
Yeah.
You also get the day every stop, all the other services and stop, whether it's across the train.
Yeah, so that's
And
where.
you've travelled Melanie before.
Yeah, so I think that the first challenge is for us to pull our data together, right? So we need to stitch it together, and we need to have it in sort of in a real-time way, reliable, and that can be scaled up, right? So at the moment, we have a lot of data in our data warehouse, with a lot of capability, but we're not yet at the stage where we could sort of be pushing. Ideally, push next best action.
But
If
you
there's a
don't know
disruption.
when the next bus is coming.
Well, we know that the next bus is coming,
And displaying
but
it,
we're
then
not.
I don't need to worry about it.
Right,
data
but
warehouse.
Well, we do need a data warehouse to pull it all together, but you need to push out, you need to sort of pull together your algorithm.
Bus is on its way. It's
Well, we do that.
5
Yeah,
minutes.
we have that. So all the buses on its way. We have about 20, lots of. Well, the complaint, right, so the complaint is, right, we get complaints about buses, one of the biggest complaints is that the bus comes but doesn't stop, right? So, and that's a lot because of crowding. So again, if we can better optimize the system, then, and we know where to put on more buses, then there are going to be potentially fewer kinds of people that don't stop. Now, the fact, if it doesn't stop, sometimes there are driver issues, and we're working on that as well, but a lot of it is because it's crowded.
Good. I think we'll probably put an end to questions there, but if Lauren's able to stay around and wait, you can ask her some more questions there. So just like to join me in thanking Lauren.